Hydroelectric dams, with tens of millions of tons of steel and concrete, have already blocked 2/3 of the world's major rivers. They block nutrient flows necessary for ecosystems to function and block fish migration routes. Over the past 50 years, the number of species of flora and fauna in freshwater bodies has decreased by more than 80%, according to the World Wildlife Fund. In fact, this loss of biodiversity can be called the sixth mass extinction on the planet, and this time, the cause of the extinction is not an asteroid or an ice age, but human activities that require more and more energy every year. Perhaps we were wrong when we chose renewable energy as our new goal. Today you'll find out that not everything is so simple. Before you is the world's largest solar power plant, Benban Solar Park, Egypt, on the outskirts of the Sahara Desert, the world's first energy park visible from space. The capacity of this power plant is 1,800 megawatts, which is 80% more than the power of the reactor that exploded at the Chernobyl nuclear power plant and released a monstrous amount of radioactive substances into the planet's atmosphere. I think that this comparison alone should convince you in favor of solar energy, because Benban Solar Park will never explode. An area of 37 square kilometers is completely covered by 6 million PV modules. But think about it. The area of the hot Sahara is 9 million square kilometers. It's almost the territory of countries such as the United States or China. It can easily accommodate 240,000 such parks. Amin Al-Habebe, professor at Nottingham Trent University, is confident that the Sahara Desert alone is capable of providing an amount of environmentally friendly electricity that is 7,000 times greater than the needs of all of Europe and easily compensates for the energy consumption of all of mankind with plenty of extra capacity. In addition, some calculations show that the Sahara Desert can turn into a green and blooming valley. After all, some of the energy of the hot, scorching sun will not reach the surface. But now I have to point out the fly in the ointment here. There are not so many places like the Sahara on our planet. Transmitting electricity over long distances by wire to Europe or America can make it several times more expensive. To deliver energy not only during the day, but also at night, an incredible number of giant batteries would be needed, which makes the project even more expensive. The problems of recycling a huge number of panels and batteries containing lead, cadmium, gallium, arsenic will raise the price of this environmental friendliness to completely unacceptable figures. After all, the volumes of such decommissioned equipment will be comparable to Everest. Solar energy fanatics simply refuse to economically calculate these threats. In addition, a sandstorm in the desert is capable of causing an energy collapse for naive consumers at any moment, covering the panels from the sun with a layer of sand. Yes, with an energy park the size of the Sahara, not everything is as simple as it seems. But I'm sure that stations like Benban Solar Park will still be developed, even if only in hot countries. The next candidate for inexhaustible energy is wind. The generation of wind energy doesn't require large areas, can be used in places other than deserts, and doesn't require transportation costs. This is the Jiuquan Power Base in Gansu Province, China, the largest onshore wind farm in the world. Its capacity is 8 gigawatts, but according to the plans of the Chinese government, in the near future it will grow to 20 gigawatts, which will be generated by 7,000 towers with giant blades. This is more than 4 times the total capacity of 6 blocks of the Fukushima 1 nuclear power plant. It's nice to know that such power no longer belongs only to traditional power generation using coal, gas, and uranium. But this is not the limit. Every year, the power of the projected installations and stations will only increase, and I hope that the planet's atmosphere will also become cleaner every year. But of course, you already guessed that wind energy is also not such a simple solution. Wind doesn't blow everywhere, and so the opportunity to build gigantic installations everywhere doesn't exist. And so the same question of the unpredictability of power generation remains. In the calm, the blades of the giant installations will be motionless. We'll have to not only turn off and defrost refrigerators in our apartments, but also shut down metallurgical plants, which require a continuous cycle of metal smelting. Wind power still can't provide an answer to all of our problems. Now, let's try to approach renewable energy sources from the other side. This is a tidal power plant located off the coast of the Yellow Sea in Siwa Artificial Bay, South Korea. It uses the ebb and flow of the ocean, the energy of hundreds of trillions of tons of water, which moves under the influence of the moon's gravity. The station's capacity is relatively low, only about 250 megawatts. Even so, the tidal power plant is already capable of fully meeting the needs of a city with a population of 500,000 people. There are only about a dozen tidal power plants on the planet today, including experimental ones, but many countries are already preparing projects for such tidal power plants. Only one of these projects, the Penjinskaya tidal power plant in the Sea of Okhotsk, Russia, has the incredible capacity of 87 gigawatts, and this is more than 1/3 of the electricity generation of all modern Russia. But as you might guess, there's a surprise for environmental optimists too. The construction cost is estimated at an equally incredible amount, more than $250 billion. Of course, like wind and solar power plants, hydropower plants can also cause skepticism. They're very expensive to build and can only generate energy twice a day for several hours. But they have trump cards that more than make up for all the shortcomings. They generate extremely cheap electricity while preserving the natural balance in ecological systems. Resources come and go, replacing each other. What was previously not considered an energy resource, then, with the development of technology, suddenly begins to be used as a source of energy. And with each new resource, humanity grows by leaps and bounds, increasing in number. The first energy source was firewood. After Europe's forests were cut down, mankind found another resource: coal. Eventually, the use of firewood declined, oil replaced coal, and then came nuclear power plants. After a few tragic disasters, we began to learn how to extract cheap energy from sustainable sources. And if we master this step, then really fantastic opportunities will open up before us. For example, we'll be able to extract the necessary raw materials directly from seawater, in which the entire periodic table is dissolved. Or perhaps we'll simply produce the elements directly, having a set of only 3 particles: protons, neutrons, and electrons. Theoretically, any atom can be assembled. However, this is a matter for the distant future. Finally, I'll share something to make you think. According to the Kardashev scale, the progress of a society depends on 2 things: energy and technology. The more energy a civilization has, the more technologies it can create. And the more useful technologies are created, the more new energy can be produced. If we learn to extract energy, for example, from our entire planet, our Earth will look like a single giant computer. And this will be just the beginning. In order to get there, we must wait for scientific advancement to be able to bend the laws of physics and other craziness. Follow the link to the next video and find out how far our civilization can go.